The binary number system is the base 2 number system. Let's convert 39 base 10 to base 2. The first thing we do when we're converting to a base is we figure out all the powers of that base. Okay, 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. We're trying to make up 39. We don't need the 64, but we will need the 32. And we can say that, okay, let's see, we're going to need a 32, that's a 2 to the 5th, so we need one of those. If we needed 2, of course, we'd be up to the next power. So we need a 2 to the 5th. That's 32. That leaves us 7. Okay, well, 2 to the 4th is 8. We don't need a 2 to the 4th to make up the 7 that we still need. 2 to the 4th is 16. We don't need that to make up a 7. Nor do we need a 2 to the 3rd, which is 8, to make up 7. Okay, we do need a 2 to the 2nd. That's 4. So we add a 2 to the 2nd. Now we only need 3 more to make up our 39. Okay? Do we need a 2 to the 1st? Yeah, that's 2, and we need 3 still. So we add a 2, and now we only need 1, and that's going to be our 1 times 2 to the 0. So we say, and again reviewing what we just did, to make up 39, we needed a 32, which is 2 to the 5th, leaving us 7. We don't need a 16 or an 8, but we do need a 4, which will leave us 3. Now the 4 is 1 times 2 to the 2nd. And then to make up the 3, we need a 2 to the 1st, a 1 times 2 to the 1st, which is 2. Now we've only got 1, so 2 to the 0 is 1. We add one of those. Then, using the place value idea, we say, okay, the binary representation of 39 is then 1 standing for 1 times 2 to the 5th, 0 standing for no 2 to the 4th, 0 for no 2 to the 3rds, 1 for a 2 to the 2nd, 1 for the 2 to the 1st, and 1 for a 2 to the 0. And then we put our base 2 on it. We can do arithmetic in the binary system. We'll note one important fact about arithmetic and binary. What do we get when we add 1 plus 1? Again, now we haven't written the base 2. We assume that we're in binary, and that's going to be accepted for the moment. So 1 plus 1 binary means what? It means 1 times 2 to the 0 plus 1 times 2 to the 0, which is 1 and 1, which makes a 1 times 2 to the 1st and a 0 times 2 to the 0, doesn't it? Okay, it's like we got 2 heel bones again, or 2 scrolls, and we add them up and we make a heel bone. But now a heel bone only stands for 2. And I guess the scroll is then going to stand for 4, right? And the lotus flower for 8, if the Egyptians had used a base 2 system. Okay, well, how do we express 1 times 2 to the 1st plus 0 times 2 to the 0? 1, 0, base 2. So 1 plus 1 is 1, 0 in base 2. We use that fact to add 1, 0, 1, 1 and 1, 1, 0. 1 and 0 makes 1. 1 and 1 makes what? Well, we just saw it's a 1, 0. Borrowing an idea from our base 10 system, we express that as a 0 here, and we carry the 1 over into the next place because, of course, this is the place for the 2 to the 2nd powers. Okay? And we add 1 and 1, what do we get? We get 1, 0 again. We write down the 0 and carry the 1. Add it to this 1, we get a 1, 0 finally. And this is how we do this sum. We'll see more of these as we get into the lecture for the next class.